So let's think through this. S plus m plus L equals 180, L equals 2m minus 1, and S plus m equals L minus 22. Now it would be perfectly acceptable to rearrange this equation so that all your letters are on the left side. As long as you would do this properly. For example, you would subtract L from both sides, and this would be S plus m minus L equals negative 22. You could do that and then solve it by the way you have seen the others solved or have been doing the other ones. But it's also worthwhile, I think, to look for some nice substitution possibilities here. And I see a real juicy one. S plus m appears both here and there. And so now I have kind of an unusual substitution. I can substitute for both variables rather quickly. S plus m is the same as L minus 22. So I could replace this S plus m with L minus 22. And look what happens. Now, we've eliminated two variables, but replaced it with a third one. So I have L minus 22 plus L equals to 180. And this allows us, because there's only L's in the equation, we can quickly able to calculate what L is. So I'm going to combine these terms. I have 2L, and by adding 22 to both sides, this 22 cancels. 180 plus 22 is 202, divided by 2, and L is 101. So we'll put that over there. Okay, well that's good. Now where should we go from there? And I'm looking at this equation, L equals 2m minus 1. I can replace L with 101 and now solve for m. So I would add 1 to both sides. That would give us 102 equals to 2m. And now divide by 2. And m is half of 102, would be 51. So there's our second angle. And the three angles must add up to 180 degrees. So these are 101 plus 51 is 152. Then S would have to be 28 degrees. So you can verify that 28 plus 51 plus 101 equals 180. All right, so now to check this problem, we would want to go back to the words of the problem. But first of all, let me write the answer. And so I'll make some room. Of course, normally I would write the answer below. The angles are 28 degrees, 51 degrees, and 101 degrees. Right, so through the years when I've given this problem on tests, for example, I've given similar problems on tests, students will, or homework, students will write the smallest angle is 28 degrees, the middle size angle is 51 degrees, and the largest angle is 101 degrees. Do you really have to tell someone which one's smallest, which one's medium, which one's large? I don't think so. And so I think from the standpoint of probably better English, this is pretty clear which one's small and which one's large. But don't forget the angle mark, the degree mark. And that's important to me, and since I'm grading your stuff, it should be important to you. And actually, if you take some more math, study some trigonometry, you'll learn that there are several ways to measure angles. And we measure them in degrees, but there's another measurement called the radian. And if you left off the degree mark, then technically you're stating your answer in terms of radians, and that's a whole different matter, and it would be incorrect. All right, so now I don't have the problem written up here, but I'm trying to remember what it was. First of all, we have the sum of the angles is 180 degrees. So do these add up to 180 degrees? They do. That's easy to verify. The largest angle was 1 degree less than twice the middle angle. All right, so twice the middle angle is 102. One less than that is 101. That checks. And then the other clue was the sum of the two smallest angles, which is 28 plus 51. That is 79 degrees. That this was 22 degrees less. I remember I was thinking 23, but it's really 22. The sum of these two angles is 22 degrees less than the largest angle. So 101 minus 22 is 79, which is the sum. All right, so there's a big principle at play there. I like to reinforce it when I can. You know, when you check your work, you check to make sure that your answers fit the given information in the problem, and it goes for word problems as well. So you could check these answers in the equations to make sure you solve the equations correctly, but there's a fallacy in doing that to check your work, because what if you wrote down the wrong equations? So if you took the word problem, translated wrong equations, you might solve those equations correctly, but you won't know that you've made a mistake unless you go back to the original problem, the statement of the problem.